Hey everybody, so these are your 3.6 notes. They cover slope-intercept form, and we're actually going to start with our explore problem. It says on a comprehensive, so that means cumulative or over everything, final exam, a professor asked each student to state the number of hours spent studying for the exam. She then used the data on student exam scores and study times to create the following model that can be used to predict an exam score based on the number of hours studied. So we have T equals 4N plus 62. And you can also think of this as Y equals 4X plus 62. So it's similar to that. So your X values or your N values, however you want to think of it, you can think of it as N or you can think of it as X. And this one you can think of as your exam score as T, or you can think of it as Y. Either one would work. You have the study hours, the time spent studying over here, which can be your X value. And you have your exam scores as whatever you'll get when you plug in these values. So if I have spent 0 hours studying, I'm going to plug that value in for X. So I'm going to plug it into 4X plus 62. So it's going to be 4 times 0 plus 62. So I would get 62. For 1 hour studied, I'm going to do 4 times 1 plus 62. So I'll get 66. This one, I'm going to plug in 2. So this would be 4 times 2 plus 62. I get 70. And you can see a pattern here as you go that they're increasing by 4. So this one would be 74, and then 78, and then 82. So part A, we already completed the table. So for part B, it says, since the exam scores increase by 4 every time, the study hours increase by 1. So the exam scores increase by 4 for every 1 extra hour studied. We can say that there is a slope then of 4 over 1, or 4, and a positive linear relationship. And we can say that it's a linear relationship because these are going up by 4 as these go up by 1. And that relationship is between the number of hours studied and the exam score. So since 0 hours leads to an exam score of, and we can look right here, 0 hours of studying leads to an exam score of 62, we can say the starting or initial value would be 62. So we're going to go ahead and use the table to graph our equation. So using the table, I had a score of 62 for 0 hours studied. I then had a score of 66 for 1 hour studied. For 2 hours, it was 70, for 3, 74, for 4, 78, and for 5, 82. And we would be able to continue this pattern then for hours 6 and 7. And just connect those dots to create your line. So part C says, where do the slope and starting value appear on the graph? So if we look for slope, slope is the steepness or the rate of change. So let's go ahead and use one of these points. We can see that from here to here, we have our slope. So from here to here, for one of these increments, it's going up by 4. And then from here to here, it's going by 1. So we can see that we have 4 over 1 for our slope. For the For the starting value, we can see that the starting value is right here. So that is where it hits the vertical axis. For part E, it says, look again at the equation. T equals 4n plus 62. And remember that we can also think of this equation as y equals 4x plus 62. Either way, it wants us to figure out where the slope is and where our starting point would be. So our slope would be, we can see that it's up 4 over 1. So this would be our slope. And we pointed out on the graph that the starting value is right here, which would mean that that would be 62. So this right here is our starting value. So we can see that whatever is attached to our variable on the right side is going to be the slope. Whatever is added, or in some cases it's going to be subtracted, is going to be our starting value. Okay, so in the Explore activity, you considered a linear relationship from 3 perspectives. We looked at it using a graph, we looked at it numerically in a table, and we also used an equation to look at it algebraically. So we're going to be able to look at different representations of equations or functions. All right, so the first definition that we have, we've already gone through slope from section 3, but we're also going to be looking at an intercept. And we're only going to be worrying about our y-intercept for this section. So our y-intercept in your equation, you will consider it to be your b value. And as a point, it will be at 0 and then whatever your b value is. So that's something that's really important. So you can see for this equation, for this line, the y-intercept is at 0, 4. All right, we're going to go ahead and skip example 1. And we're going to go straight into the next page where it talks about slope-intercept form. So it says the linear relationships can be drawn in the form y equals mx plus b. And this is going to be something that's really important that shows up throughout this section. So this is in slope-intercept form. And when an equation is in slope-intercept form, the coefficient of x is the slope. So whatever is in front of x is the slope. Whatever is added or subtracted is your y-intercept. Now, something that I do want to point out is you can also have this equation written as y equals b plus mx. So in that case, the b would be the part that's added or subtracted, and the m is the coefficient of the x value, so that would be your slope. Okay, we're going to go ahead and look at the following equations down below. For example 2, we're going to look at each linear equation and identify the slope and the y-intercept. So looking at A, in front of our variable, we have -3. So that -3 is going to be our slope. So we can say m equals -3. We can also think of it as -3 over 1 because we usually think of slope as the rise or the run. We're going to go back in a little bit and do our y-intercepts after we look at our slope. So for the next one, for this one, you have x over 2. Now, invisibly in front of an x variable is a 1. So you can think of this one as being the same as y equals 1/2 x minus 8. So for this one, m would equal 1/2. For c, this is the same as y equals 4 minus 1x. So the number in front of your x is -1, or you can think of it as -1 over 1. Either way is fine. For D, the number in front of x is -6.5, so that would be your m value. For E, it is similar to letter B, where you can put 1 in front of your x, so m would be equal to -1 over 3. For F, this one doesn't have any x term. So this is the same as y equals 0x plus 4. So if there are no x terms, you can just think of m as being equal to 0. And we'll scroll down and do G last. Okay, for the other part, we're going to go ahead and write the y-intercept. And remember that your y-intercept is going to be at 0 and then whatever your b value is. So for this one, we can see that our b value is what's added or subtracted after that. So b is going to be equal to -2. So my y-intercept is at 0, -2. For letter B, -8 is subtracted. So my y-intercept will be at 0, -8. For C, the other number not attached to x is 4. So our y-intercept is going to be at 0, 4. For D, 2.5 is added, so this will be 0, 2.5 for your y-intercept. For E, nothing is added. So if you don't have anything added, you can think of it as adding 0. So your y-intercept would be at 0, 0. And for F, for this one, remember that we rewrote it like this. So 4 is actually added. So our y-intercept would be at 0, 4. For G, you can, if you want to rewrite this one, you can think of it as w equals -2t plus 100. So your m would be equal to -2 or -2 over 1. And the y-intercept would be at 0, 100. All right, that covers how to find your x and y your slope and your y-intercept. Okay, the next thing that we are going to do is we are going to go over graphing a linear equation. I am going to give you guys the quickest way to do it. So we're going to skip the top part here of example 3. And we're going to go straight to the bottom. And I'm going to show you guys how to graph your equation. So let's say that we have y equals -5x minus 4. I am always going to start graphing by using the y-intercept. So we're going to start at the y-intercept, which is at 0, -4. So that's my first point that I'm going to plot. I am then going to use the slope. So then use m equals, and our slope is -5. So we can think of this as -5 over 1. And so whenever you have a whole number, you can just put it over 1 in order to figure out how far you go over. So because it's -5 over 1, we're going to think of it as go down 5 because it's negative, and then over 1. So I'm going to go down 5 over 1. And that right there makes my line. Make sure that you put arrows on the ends of your line. Okay, we're going to go ahead and jump to example 4. This one, the same idea is going to work for graphing this one. You're going to start at your y-intercept. So for this one, we're going to start at 0, 5. That's the y-intercept. And then we're going to look at our slope, and we're going to, for this one, a slope of -3/4 means we're going to go down 3/4. And we're always going to move to the right, because the direction is determined by if we go up or down or not. So I'm going to go down 3/4 and draw the arrows at the end of your line. Okay. For example 5, it says kudzu vines are invasive and can exhibit incredible growth in favorable conditions. Suppose a vine's length is given as L equals 525 plus 9t. L is going to be inches, and t is going to be the number of days since July 1st. We're going to identify and interpret the slope and y-intercept. So let's first identify the slope. The slope is 9, or 9/1, because that's what's multiplying with the variable. The y-intercept is at 0, 525, because that is what is added on the same side as your variable. Okay, so we're going to also interpret what that would mean. So when you look at the slope, you want to think of it as it's 9 what per what. And so when we look at this, it's going to be with inches and days. So we can say that for each day after July 1st, the vine grows 9 inches. And when we look at the y-intercept, remember that the y-intercept represents our starting value. So we can say at day 0, or July 1st, the vine is 525 inches long. Okay. Example 6 says for each problem, use meaningful variables, and I'm not going to worry about us using variables other than x and y. I think it's easier for us to use that, to write linear functions to model the situation. And then I'm not even going to worry about us interpreting it, so I just want us to write what these would be with mx plus b. So you're always going to keep your y value, and you're going to keep the x there. So you're not going to plug in anything in for the y or the x when you write an equation, because you want your equation to represent all the different possible ways that we can have values plugged in. So we're going to think of it as y equals blank x plus blank. And sometimes it could also be minus something. All right, so this one says, model the cost if you buy an iPod for $200 and download songs for $1.29 each. All right, so when I read this one, I'm looking at two different values that could get plugged in. Now, the $200 is really just a one-time cost. The $1.29, that word each, clues us into for every song that we download, it's going to be $1.29 more. And remember also, so that kind of hints to us that that would be our slope, or m. And also think of your y-intercept, or your b value, as your starting point. So this makes sense that this is our starting value, or b. All right, so I'm going to write my equation. I'm going to have a blank in front of x, and then I'm going to add something else. So we have our slope, which will go in for m as $1.29. And we have our value of 200 as our b value or our y-intercept. And that's all that we have to do. For B, it says model the weekly salary of a salesman that a salesman earns if his salary is a combination of his base salary and a commission of sales. His base salary is $500 and he makes $50 for each sale. All right, so we have that word each, which gives us a clue. So that means for every sale that he makes $50 more. So that's telling me it is slope because slope is a rate. And this says his base salary, which means what his salary starts with. So this is our starting value, or B. So when I write my equation, I'm going to have my M, or my slope, go right there as 50, and the B value will be added or subtracted. This is a positive, so it's going to be added. Okay. Now we're going to go ahead and just practice a few other examples just to make sure that you guys get the hang of it before you go and do your homework. Okay, so for these ones, I'm just going to do a few of them. This one, your M would be equal to 4 or 4 over 1 because that's what's in front of your X. Remember that you're going to write these as 0, B. So you're going to write them as the point for the y-intercept. So this one has a 2 being subtracted, so that would be at 0, -2. This one, 0.5 is in front of the x, so m would be equal to 0.5, and your slope would be at 0, -2.5. For this one, your x variable has a minus sign in front of it, and it has an invisible 1. So m would equal -1 or -1 over 1. 5 is the other number, and it's positive. So your y-intercept would be at 0, 5. For 4, 1 is in front of your x variable. So m equals 1 or 1 over 1. And 3 is added. So your y-intercept would be at 0, 3. And lastly, this one doesn't have anything added or subtracted, so that's the same as adding 0. So the y-intercept would be at 0, 0. And your slope is what's in front of your x, so that would be -2 or -2 over 1. Okay, in the next few problems, we're going to go ahead and graph some equations. I'm just going to write down what the equation we're graphing would be right above each of these. So for number 6, we're going to graph y equals 4x minus 2. So remember that we are going to start by graphing the b or the y-intercept. So that's our starting spot. So we're going to start at -2. All right, so I put a point down at -2, and now I'm going to use my slope. My slope is 4 or 4 over 1. So I'm going to go up 4 over 1. And if I want, I can do that again. I'll get a little bit nicer of a line. And that's my equation. All right, for the next one, number 7, we're going to graph y equals 5 minus x. So for this one, my slope is -1 or -1/1, and my y-intercept is at 0, 5, because we have a positive 5. So I'm going to start at the y-intercept. So I'm going to start at 0, 5. And then my slope is down 1/1. So it's just going to be down 1 to the right 1, down 1 to the right 1, and so on. You can keep going to make a little bit of a straighter line, and make sure that you have your arrows on the line. Okay. We're going to go ahead and do a few more on the next page. For number 8. This one, let's go ahead and do x plus 3. Oops. We'll just make it x plus 9. That's fine. So for this one, you would start at positive 9. So your y-intercept would be at 0, 9. Your slope is 1 or 1/1. So you would just go up 1/1, up 1/1. And that is your graph. We'll do one final one for graphing. We're going to graph y equals -2x. So for this one, this is the same as y equals -2x plus 0. So your y-intercept would be at 0, 0. Your slope would be -2 or -2/1. So start at 0, 0. And for this one, you're going to go down 2/1. I'm going to do it a few more. Down 2/1. Okay. Connect your dots. There you go. The final problem that we're going to look at for today is number 11. A bus company begins a business with a fleet of 72 buses. So that kind of gives us a hint. That's our starting value. Each year, they increase the size of their fleet by 2 buses. Complete the following table and also write a linear equation. Okay, so we're going to have y equals blank x plus blank. We know already that our starting value is 72. And that leads us to believe that 2 would be our rate or our slope. And we can look here. Yep, it's going up by 2. That is our slope. So the next value after another year, so after 2 years, we would have another 2 added. So that would be 76 buses. And then 78, keep going up by 2, 80, and then 82. All right, so we finished our table, and we also have our equation. Okay, we're going to go ahead and pause or end the video for today. This is everything you need to know to finish up all the homework for section 6. Have a great day, everybody.